All right, number 10, you made it. Here's the last one. Appreciate you hanging in there. So whether you're doing this at home on the weekend or at night, or you're here at tutoring doing this after school, either way, appreciate your effort, and that's what it's really about, is putting in the time, putting in the effort. You can always get better, and so I think you're going to be proud of yourself when you, after having completed this, you retake the test and see your grade go up. I think it'll all be worth it. So look at number 10. So we're graphing, well, we talked about graphing lines, we talked about graphing inequalities, and then this is the last one. In the last unit, we talked about solving absolute value equations, and so now we're just looking at the graph of an absolute value. Well, the most basic graph of just y equals the absolute value of x is this graph right here. And you know, if we were going to do a table and we could kind of show you why that's the case, but what we're really looking at on this one is what happens when you throw other numbers in there. So if the most basic one is just y equals absolute value of x, where it starts at 0, 0, what happens when you throw a number at the end? What happens if you throw a number on the inside there? And it should be mentioned, by the way, too, is that just even the graphing we've done, y equals x, is that y equals x. Let me come back to my calculator here for a second. The most basic, just y equals x, right, is an equation, that goes through the origin like that. And so that's a starting point of 0 and a slope of up 1 over 1. And then so what we've done is we've said, well, what happens when you throw other numbers in there? Well, that's what changes the slope. It changes the y-intercept. So that's what shifts the graph around. Right? So we're kind of doing the same thing that we've done with just equations, but now we're doing it with an inequality. So what we want to figure out is what happens when you put these other numbers into the mix. Well, I want to show you kind of an animation of what happens here. So here's just basic y equals x. And then notice what happens. You see this h? That's the number that's inside with the x. And then k is this last number that's at the very end. Well, look what happens as the k changes. So what you notice is that as the number at the end goes up, well, so does the graph. And that's actually true for a line as well, right? As the y-intercept increases, it shifts the line up the graph. As the y-intercept decreases, it shifts it down the graph. So you notice now that the k is in the negative territory, and so it's just sliding the graph, right? So it's this V shape, and so the difference is the V is either sliding up or it's sliding down. So that's what the last number tells us, is it tells us where that V shape is on the y-intercept. We're going to pause that there. So that tells us the y-intercept. So whatever the k, right, this last number that's out there, that tells me the y-intercept. So this is the y in terms of like x comma y. And what we notice is that it just was the same. So if this number is negative, then it meant it went down, right? So this just stays the same. So if this is a negative 4, that means the y value is going to be a negative 4. And then let's look at what about if there's a number on the inside there. So if I look at the number that's on the inside there, which would be h, what you notice, oh, it's actually going in opposite directions, right? So what you see is that actually as the h value gets larger, it actually shifts to the left. And so you notice that it's going in an opposite direction. Well, it's inside that absolute value. You know that absolute value ends up taking kind of the opposite. A negative turning into a positive. So that's kind of what's happening there, is that you'll notice that there's actually kind of an inverse relationship there, is that if h is negative, then it's actually on the positive x, and if this number is positive, the graph is actually on the negative end of things. So we can then make that Pause that. So then what we could say is that, well, whatever this number is, that's the x of where the v is located. But what we ended up doing is we ended up taking the opposite. So we'll say OPP for opposite. So that actually would be a -2, -4. And you see this word vertex right here. Vertex just refers to, let me go ahead and write this down. Vertex refers to the turning point of the graph. What we mean by turning point is that if you notice, again, this V shape is that it's going down and then it bounces back up, right? So it's going down and then it goes back up. So this is what we would call the vertex, or the turning point. So what happens is that if there's other numbers that are in there, that just changes where the vertex is located, or the point at which it kind of bounces back up. So I'm at -2, -4. So that's telling us where the vertex is. And then what you notice how the line, it just goes up 1 over 1, up 1 over 1, up 1 over 1. And it's the same thing on this side as well. So we just go up 1 over 1, up 1 over 1, and then I've got a V shape that looks like that. Okay. So we'll come back and look at the graph of absolute value functions more. But within this unit really was just to introduce you to the idea of what we call the vertex, and then how to find that vertex. So the x value, the x of the vertex, opposite of what's the number that's there, the y value stays exactly the same. All right, so try 10.2 and 10.3, and then we're all done. All right, so 10.2, show you got a vertex of 3, 1, and 3, 1 would be a V from that point right there, and then vertex for number 10 would be 1, -5. So you'd have a vertex at 1, -5, and the V would kind of go out from there. All right, so that's it. Thanks for hanging in there with us. And hopefully now you feel a lot better about graphing and understanding rate of change and slope and y-intercept and all that good stuff. So we'll conclude here, and now it's time for you to redo the test.